The goal of curve fitting using PSpice Advanced Analysis is to optimize a circuit output against a target specification represented by a waveform. Normally, the optimizer capability in Advanced Analysis is used to optimize against defined measurements and values. But in this example, we're going to use curve fitting capability of optimizer to match the output curve of the design to a reference curve. The example design seen here is a bandpass filter, and the design specification will be represented using XY points. The objective here is to optimize the phase margin and optimize the gain margin. Using two separate specifications, not only will we try to optimize the design against the two curves, we want to curve fit the design output to both of these reference curves simultaneously. Opening Optimizer from the Advanced Analysis menu, the first step is to decide which variables will be allowed to change in the process of matching the output of the design to the desired target curves. The list of components and component values are the parameters that Optimizer will work with. In this case, we are not interested in the circuit voltages, assuming the design voltages are fixed. For this example, only the values of the capacitors and the resistors will be allowed to change. Our selection will be passed over to the Optimizer engine. Even with the components and the component values in the optimizer list, specific parts can be excluded or locked from the optimizer, preventing those components from being changed. The rest are available for optimizer to adjust in the attempt to fit the design output to the specified target curves. The specifications we will add for the optimizer to adjust the design against will be trace expressions versus just defining a fixed goal value. For our trace expression, we will pick phase and optimize against the phase of dB output. We want to pick from a reference point, which can be done from a text file containing the entire reference graph. From the text file, we will pick the column that is marked phase. This becomes the target specification, and similarly, the column marked voltage, which represents the gain. Now that the two reference curves have been defined, we will start the optimizer. The green line displayed are the gain margin and the phase margin respectively. After a couple of initial runs, they begin to approach the red lines that represent the target specifications we defined. After a few more runs, the optimizer engine, the least square quadratic engine, matches both the target curves. The new values recommended by the optimizer are shown in the current column. These recommended values can be back-annotated to the schematic design to achieve the desired circuit behavior. Using this curve-fitting methodology, Advanced Analysis Optimizer can be utilized for more complex specifications with a combination of target curves and fixed value measurements.